Okay, welcome to Lecture 1. We're going to do Chapter 1, Section 1 on linear equations. So what I'm showing you right now is just a page of the textbook. And I also mentioned earlier that if we go back to our home page, if you go down to the module labeled Chapter 1, there's a Chapter 1 worksheet link. And you can actually click on that link and come up with worksheets. I'm actually going to follow the worksheets I've typed out. Normally, in normal cases, I teach this class face-to-face and not recorded. But if you would rather follow along using the Pearson eText, Chapter 1.1, they will mostly be identical. Very little changes will be made. But I'm going to go ahead and use the worksheets that I made, and this is for people when I teach the class face-to-face. This is what they can print out and bring with them to class because they usually don't have access to the eText during class. So our first objective is just going to be to define and to solve a linear equation. And then we're going to identify solution sets of linear equations and classify equations by their solution sets. So many times I will add just a little bit of extra information. So my definition is of a linear equation in the variable x. So remember, a variable is a letter that stands for a real number. That real number is an unknown number to us, but it always stands for a number. And since most of our equations, that variable or unknown will be denoted by the letter x, I just simply put that in the definition. We can also have linear equations in the variable t, the variable s, the variable y. Any variable will work, but what the example I'm giving you is a linear equation in the variable x. So let a and b be real numbers. Those are fixed. They don't change. You will actually know what they are. But this is a general definition. Let a and b be real numbers where a is not equal to 0. That's the only restriction. The general form of a linear equation in the variable x is given by ax plus b equals 0. So let's take a look at that. So we have a regular linear equation. If I can get things to right, I'll be happy. And it's not. Very first attempt, and it's not. Ax plus b equals 0. So what I'm doing right now, let me go back, is I'm just writing down this right here. And I'm going to give you some specific examples. So 7x, I always cross my 7s. It's an old habit. I don't know where I picked it up. Plus 3 equals 0. In this case, a is equal to 7. B is equal to 3. X divided by 2 is equal to 0. Is this a linear equation? Well, every linear equation can be expressed this way. And our only restriction, if you recall, is that a, which is called the coefficient to the variable term, a is not equal to 0. So I can rewrite this, x divided by 2 is equal to 0, is 1/2 times x. That's the same thing as x divided by 2 is 1/2 times x, plus 0 is equal to 0. And notice that's in the form ax plus b is equal to 0. So let's go back. So the solution set of a linear equation is the set of all values of the unknown variable. In this case, that unknown variable is x, which make the equation a true statement. So let's go back to here and let's look at this first example. So I have 7x, I'm going to change it, plus 14 is equal to 0. Now, we can solve this, and hopefully you already have the tools to solve this. But notice that if I say let x be equal to 2, then if I plug in the value of 2 for x, I get 7 times 2 plus 14 is equal to 14 plus 14, which is equal to 28. And we want it to be equal to 0. So our conclusion is x equals 2 is not a solution to this particular linear equation. But if you're close, that was an obvious guess, so we're just guessing right now. Maybe instead of using 2, maybe I should try x equals minus 2. That gives me 7 times minus 2 plus 14. Well, 7 times minus 2 is minus 14 plus 14. That does give me 0. So x equals minus 2 is a solution. Notice I used the word a solution rather than the solution, because as it turns out, the solution set is the set of all values of the unknown variable x which make the equation a true statement. Now with linear equations, there are 3 possibilities. There is exactly one value of x that makes the equation true. The other possibility is no values of x make the equation true. And the final possibility is every choice, any real number that I substitute in for x will make the equation true. And that's exactly how we classify linear equations. There's many ways to classify equations. If you think about it, I've already classified an equation as being linear. And that means that it can be written in the form ax plus b equals to 0. There's another classifications of equations based on their solution sets, not by their form ax plus b equals to 0. And here is that classification. I just want to give you an example. We can classify animals by whether they are mammals or something else, fish or amphibians. We could also classify animals by those that live in the desert versus those that live in tropical rainforest. There's many different ways to classify collections of things that we see in our daily lives. We can classify cars by their color, or we could classify cars by their make, or we could classify cars by their model. So the fact that I'm actually giving you another classification of an equation should not come as a surprise. But here's the end result of that. So 3 different classifications. Equations whose solution set contains some numbers but not others are called conditional equations. That means it has one solution, but there are solutions, numbers that work as solutions, and numbers that don't work as solutions. This example that I just gave you right here, if you think about it, 7x plus 14 is equal to 0 is a conditional equation, because x equals to 2 is not a solution, whereas x equals to minus 2 is a solution. So we know that that particular equation is a conditional equation. The second possibility, or the second classification, are equations whose solution set is empty. A solution set, remember, is just a set of all of the solutions, all of the numbers that make the equation a true statement. And it may be that no numbers make the equation a true statement. In that case, we say the set is empty, and those are called contradictions. And 3, equations whose solution set contain every real number or all real numbers are called identities. So what we want to do, so those are, just to summarize really fast, we've defined a linear equation in the variable x. That's one classification of equations. Another classification of equations is by their solution set. 2 different classifications of equations. But one of our goals was to solve linear equations. So this is what we want to do. We want to transform an equation in one variable to one of the following end results. X is equal to b, where b is a particular number. X is our unknown, and b is the proposed solution. In this case, there is only one solution, and in that case, by the classification of their solution sets, this is called a conditional equation. If we transform a given equation as to a is equal to b, where a and b are not the same numbers. For example, suppose I were to look at an equation and I go about and I solve it and I get the following. 3 is equal to 0. That's what I mean a is equal to b, where a is not equal to b. In this case, a is equal to 3 and b is equal to 0, and clearly they're not equal. The other case would be like x is equal to 3. Notice the difference. In that case, there is no solution, and those types of equations are contradictions. And the final case is that we get x is equal to x, and literally that says x is equal to x. Absolutely. Like if it rains, then it rains. And x is our variable. So x is equal to x. X is always identical to itself. That's the reason they're called identities. Or we have a is equal to a. So when I'm using my techniques to solve an equation, I might get to my last line and discover that I literally have x is equal to x. Or I might have something like 10 is equal to 10. So this is a variable, and this is a particular equation that says 10 is equal to 10. If I reach either of these two endpoints, then the equation is an identity. So I'm going to tell you and give you the heads up right now. Most of the equations that we look at are going to have, most of the linear equations that we look at and examine will have exactly one solution. A few of them will have no solutions, and some of them will be identities for every number x. But the majority that nature seems to give us are those that have exactly one solution when the equation is a linear equation. So how are we going to solve these? We're going to use the addition property of equality. So here is the way I state it. It's a very mathematical way. And then I'll give you a visual way. If x is, I'll state it one way and then I'll state it another. x equals to b implies x plus c is equal to b plus c, where x, b, and c stand for real numbers. So wow, what does that mean? Implies is just another way to say this is the following. If x equals to b, then x plus any number c is also equal to b plus any number c. So let me give you an example of that. In mathematics, we deal with a lot of generalities. So let's think of a true statement. Let's say x is equal to 10. So that's kind of like saying x equals b. In this case, 10 is equal to b. Now let's let c be equal to 3/2. I purposely chose a fraction. It could be any real number. So if I add x plus, if I add 3/2 to x, then I have to do so to the other side. Since x is equal to 10, then if I add 3/2 to x, then that's the same as 10 plus 3/2. Many times I wish I had, so many people in my family have drawing skills. I do not. So imagine that this is a scale that's balanced. And I'm not going to get very elaborate. It's just a joke if I try to. And I have 3 marbles on one side and 3 marbles on the other. So their weight is equal. It's balanced. So if I add another marble to this side, to maintain the balance, I have to add the exact same marble onto the other. And what we want to do is we want to make sure that our equality holds. If I have x equals to 10 and I add to one side 2, but I don't add the same number to the other side, if I add 2 to one side and 3 to the other, then this is no longer the case. Let's show why. Because I know that x is equal to 10. Is the equality still hold? Well, 10 plus 2, is that equal to 10 plus 3? Heck no. We broke the equality. And that's the number one error that I see in algebra, is you do something where the equal sign no longer holds. And it's something literally as trivial as this. You add 2 to one side and 3 to the other. Or more commonly, you'll have x is equal to 10, and then you'll go something like, this is the end point, but you'd go like x minus 2 is equal to 10 plus 2. So you subtract 2 and add 2. Can't do it. In this example here, it would be like, where's my eraser? I'm going to try to use visuals anytime I can. It would be like subtracting one marble from this side and adding 2 marbles to this side. The equalities broke, and the resulting scale is no longer balanced. So most of this should already be familiar to you. Basically what this says is, if I have an equation, I can add the same number or subtract the same number to both sides, and the equal sign still holds. The multiplication property of equality, as long as I don't multiply both sides by 0, then x is equal to b. If x is equal to b, then cx is equal to cb. In other words, the way this is stated here is a little bit better. X equals to b, that's one equation, a linear equation. CX is equal to CB, they're equivalent equations. And what's an equivalent equation? They're equations that have the same solution sets. And that's literally how we solve problems. We use those two properties to transform an equation like this to an equivalent equation, another equivalent equation, and another equivalent equation until I've got the same, until I get to the answer. So let's go ahead and use this. So this should be, for all of you, a review. You should have already passed intermediate algebra or its equivalent. So a lot of this is just a review. I'm going slow to help you ease into it. If this seems really, really difficult to you and you're panicking right now, you may be in the wrong class. Email me and talk to me if that is the case. So this is example 1. So we have 3 times 2x minus 4 is equal to 7 minus, in parentheses, x plus 5. So what we're going to do is I'm going to use the distributive property to simplify both sides. So I'm going to multiply 3 times 2x. So 3 times 2 is 6 times x. That gives me 6x. Then I'm going to multiply 3 times minus 4. So 3 times minus 4 is minus 12. Over here, 7's going to stay put. This is the same as, if you want, is minus 1 times x plus 5. So that's minus 1 times x. That gives me a minus x. Sorry, I don't remember which color it was. And minus 1 times 5 is minus 5. So that's the first step. I use the distributive property. And I'm not going to go over that because it's assumed you know what that is. And now the next step is going to be collect like terms. So these terms are not like. There's nothing I can do here. But over here, I can collect the 7 minus 5. Those are like terms. And then move the minus x to the other side. So this is collect like terms. Simplify is, if I actually have like terms to collect, I'm going to simplify. 7 minus 5 is 2 minus x. So now what I want to do is get my x terms on one side and my so my x terms are terms that have the variable x. So the minus x and the x. So what I'm going to do is I'm going to add plus 12 to both sides. The result is 6x. Why did I choose plus 12? Is I want to get rid of this. I want just a variable term on the left-hand side. 2 plus 12 is 14 minus x. So I'm getting closer to my final goal. Now what I want to do is I want to move the minus x over here. And I'm just doing this a different way. Some of you have already done this in your head and you're ready. If that's you, you can skip this entire video or just go to the sections that you want to review. So the next thing I want to do is get rid of this x over here. So by using the addition property of equality, I'm going to add, sorry, I'm not adding 14. What I'm going to do is I'm going to add an x to both sides. getting ahead of myself. So I'm going to add an x. So 6x plus x gives me 7x. And 14 minus x plus x gives me a 14. I'm almost there. So now I know how much 7x is. I want to know how much 1x is. So what I do is I divide both sides by 7. So that's the same thing as multiplying both sides by 1/7. And the final result is 7 divided by 7 times x is 1x. And that gives me x is equal to 14 divided by 7 is 2. So that is our proposed single solution. I got x is equal to 2. So this, if I'm right and I did not make an error, this equation is contingent. It has one solution. How do I know I'm right? Well, let's go back up to the original equation and plug in x is equal to 2. So here's the original equation. So let's go back. And I'm only going to do this once, but it's a good idea to do. 2, x is equal to 2 minus 4 is equal to 7 minus 2 plus 5. Well, this becomes 3. 2 times 2 is 4 minus 4. And this becomes 7 minus, what do you do in parentheses? You do parentheses first. That's 7. So I don't have room, but I'm going to go ahead and don't have room to do this. So I'm going to go ahead and erase really fast. I'm going to erase this right here. So while I'm doing this, I'm just going to emphasize my first lecture is going to be the slowest lecture. Normally we'll move through this much faster, and I don't mind going a little bit slower on this first lecture because you can fast forward. So this is 3. Four minus 4, that's 3 times 0, is equal to 7 minus 7, that's 0. 3 times 0 is equal to 0, so I get 0 is equal to 0. That's a true statement, so that means x equal to 2 is correct. The reason I went ahead and did that is the book tells you to do that, and it tells you that once you get an answer, you can actually check your answer. That's the cool thing about algebra, is you can check your answer. So I'm going to go ahead, and I'm hoping that's going to be enough of a review. So now let's solve this next one. It has the dreaded fractions. And we're going to see fractions again and again and again in this class, and there's no getting away from it. But we're going to actually make this so much easier by finding the LCD of the denominators. So we have 2x plus 4 divided by 3 plus 1/2 x is equal to 1/4 x minus 7/3. So we need to find the LCD of 3, 2, and 4. And what I will do is I will post a video that shows you how to do that. But I'm hoping you can see that the LCD of 3, 2, and 4 is equal to 12. Usually people can get the LCD right. 12 is the smallest number, such that 3 divides 12 evenly, 2 divides 12 evenly, and so does 4. So once I find the LCD of my denominators, 3, 2, and 4 are my denominators, what I'm going to do is make this so much easier is I'm going to use the multiplication property and multiply both sides by the LCD. It's going to make our life so much easier. And this is going to be one that you're going to want to practice. You're going to see problems like this all the time. So notice I'm multiplying the entire left-hand side by 12. So I group the left-hand side with parentheses. Now I'm going to do the same thing. I'm going to multiply the entire right-hand side by 12 also. And now I'm going to go ahead and use the distribution property. So 12 divided by 3 is 4. So 4 times 2x is 8x. And 4 times 4 is 16. So that's all I did. I said 12 times 2x plus 4 divided by 3 is the same as 12 divided by 3 times 2x plus 4. And 12 divided by 3 is 4. So really all I did is I did 4 times 2x plus 4, and that's what gives me 8x plus 16. So that's distribution on the first term. Now let's distribute on the second. 12 times 1/2 times x is the same as 12 divided by 2 times x. And 12 divided by 2 is 6, so that gives me 6x. You should pause the video right now and see if you can get the right-hand side. 12 times 1/4 x is the same as 12 divided by 4, which is 3 times x. So that's 3x. 12 times minus 7/3 is the same as 12 divided by 3 times minus 7. 12 divided by 3 is 4, and 4 times minus 7 is minus 28. So we have 18x plus 16 plus 6x is equal to 3x minus 28. So let's go ahead and collect like terms. 8x plus 6x plus 16 is equal to 3x minus 28. 8x plus 6x is 14x plus 16 is equal to 3x minus 28. Now I'm going to go ahead and do something slightly different from what I did before. Is I'm going to say, okay, I want to move the 16 over here. And I want to move the 3x over here. Well, the 14x is going to stay. I can move the 16x to the other side. The price I have to pay for that move is it changes its sign. The 28 stays. When I move the 3x to the other side, I can do it, but the price it pays is the sign has to change. So now I have x terms on one side and constant terms on the other. 14x minus 3x is 11x. And minus 16 minus 28 is the same as 16 plus 28 with the signs changed. So that's minus 44. Oh, how nice. It's going to work out pretty nicely. Now I know 11 times x is equal to minus 44. I want to know how much 1x is. So I divide both sides by 11. Dividing both sides by 11 is the same as multiplying both sides by 1/11. So 11x divided by 11 gives me a single x. And minus 44 divided by 11 gives me a minus 4. And that is our answer. So I'm going to skip. I'm not skipping anything, am I? multiplication property of equality. Did I skip a page here, people? We solved that. 3 times 2x minus 4. Okay. Good to go. So now we're going to do example 3. And we're asked to determine what type of equation each is. State the solution set. So again, if you don't know what you're being asked to do, you have to go back and you have to read the definitions. So let's just work on number 1. I'm going to do number 1 and number A and number B, and then you all can do number C. So basically what we're going to do, this is example 3, A. We're going to solve 2 times x plus 4 plus 3x is equal to 8 minus x. As always, we're going to use distribution to simplify the left-hand side. So minus 2 times x is minus 2x. Minus 2 times 4 is minus 8. That gives me plus 3x. It was already there. Is equal to x minus 8. I suggested this step you simplify. You collect like terms first. 3x minus 2x leaves me an x. And the 8, I didn't do anything with that, is equal to x minus 8. Now what I want to do, I want to, if you're okay with realizing that x minus 8 is always equal to x minus 8, you're fine. But let's do this. I want to move the 8 to this side and the x to this side. So when I do so, when I move the x to this side, it changes sign. When I move the 8 to the other side, it changes its sign. So x minus x, by definition, is always 0. And 8 minus 8 is 0. So I have the form a is equal to a. So that signals that this is an identity. Now at this step right here, there are things you could have actually done, and I want to just show you that really fast. So let's go ahead and go back and just look at this step. You have choices many times in solving things in algebra. Suppose you broke down what I did right here. I did two things. I moved the 8 and I moved the x. Suppose you broke it down and you just moved the 8 first. I'm going to move the 8 over to here. So that gives me x is equal to x minus 8. What's the price you have to pay? You have to change the sign. So that gives me x is equal to x minus 8 plus 8 is equal to 0. So that gives me x is equal to x. And that's the other form we have, if you go back a few pages, that also signals that this type of an equation, it's a linear equation which is also an identity. So not so bad. Let's do example number 2. So this is example 3. I'm doing this here. When I upload these to YouTube video, I'm going to try to put links so you can go straight to the examples. It helps you. I know some of you are going to be fast forwarding, and that's perfectly fine. I want to fast forward myself, but I'm going purposely slow on this first lecture. And once you get into the groove and your algebra and your math thinking caps are reactivated, we'll start going faster. So here again, I want to solve for x. So what I want to do is I want to move this minus 4 to the other side because I want variable terms on one side, constant terms on the other. The 5x stays put. The 11's over there already. The minus 4, when it goes to the other side, pays the price of changing its sign. So I have 5x is equal to 15. So now I want to know how much a single x is. I know how many 5x's are. So to find what a single x is, I divide both sides by the coefficient of x. Same as multiplying both sides by 1/5. So 5 divided by 5 times x is 1 times x, which is equal to x. And 15 divided by 5 is 3. So this is the classic result when our equation type is considered contingent. So you're already, I'm hoping you're already thinking about the process of elimination. So example 3. Sorry, we're actually on C. Is 3 times 3x minus 1 is equal to 9x plus 7. Use distribution. So 3 times 3x is 9x. 3 times minus 1 is minus 3. So here you can choose to do this into 2 steps or 1 step. But I want to move my minus 3 over here and my 9x over there. That gives me my variable terms on one side and my constant terms on the other. When I move the 9x over, it has to change sign. And when I move my 3 over, it has to change sign. It becomes positive. So 9x minus 9x is always 0. If I give you 9 times something and then I take away 9 times something, you have 0 of that something. And 7 plus 3 is 10. This is the form this is a statement that says A is equal to B when A really isn't equal to B. So this is a contradiction. And what is the solution? Contradiction is no solution. I forgot our instructions were to write the solution set. So the solution set here is there are no solutions. You can write a solution set, an empty set that way, or you can use the symbol with the 0 and a slash. That means the empty set. Over here, in this case, our solution set, remember our set, these are set symbols, just contain one element, which is 3, and the one right before that is we discovered that every element is a solution. So the solution set for this is, I'm going to allow you, here's one way to do it. I'm going to give you a symbol. See that R there with those 2 bars? That actually is a symbol that means the set. It means the set of real numbers. Another way, probably the way my math lab wants you to do it, is x such that x is a real number. I'm pretty sure my math lab will not accept this symbol, but that's a symbol that you should be aware of, and they'll want it to be given to you that way. So here, and this is the only part, this, for some reason, this is problematic for students. So what we're doing in this case is we're still solving linear equations, but we're going to be solving for a specific variable. So this is definitely one you need to practice. So I have I, which stands for some real number, is equal to P times R times T. And it says solve for T. This means T is our unknown. In other words, T is our variable rather than X. Literally, if you want to go back and rewrite that and go X is equal to PRX and then solve for X, and at the very last step replace X with T, that's fine. But it's really not that difficult. Let's go ahead and do it. So I've got to isolate T. So if you want, you can say, okay, this is some numbers, P times R times T. So how do I get T by itself? Well, if P times R is not 0, then if we just divide both sides times P times R, then P times R divided by P times R on the right-hand side, gives me 1T. So the answer is I divided by P times R. I'm going to stop right here for just a second, and I'm going to give you this consistently is the type of problem missed by students after student after student. So let's give you another example. Suppose I had 10 is equal to 3 times 5 times T. I is equal to P times R times T. I'm hoping you would immediately just divide both sides by 3 times 5 and declare that 10 divided by 15, because 3 times 5 is 15, is equal to T, or if you wanted to simplify that, 2 divided by 3 is equal to T. So that's one way to proceed. If you're given a formula, just make up some easy numbers and see what you would do. In this case, let I equal 10, P equal 3, R equal 5. That's I is equal to 10. And solve it that way, and then that tells you what to do up here. But literally, the mathematical way to do it is just to think, okay, that's fine, I can do this. All I'm doing is identifying the variable. Here we're going to solve for P is our unknown. There will be almost, and there's a very good chance that this will be on the test. So what do you do? I'm solving for P. So P is my unknown. So I want all my unknowns on the same side. So I'm going to take my minus P and add it to both sides. So that's going to give me A is equal to P R T. What's the price I pay? Change the sign. Plus P. Now what do? I notice that both terms share the common factor. And what is that common factor? It's P. So I can divide out or pull out a P from both sides. The greatest common factor, remember that? So PRT divided by P leaves me an R and a T. P divided by T leaves me a 1. Wow, I'm almost there. Remember, I'm solving for P. So A is equal to P, which is my unknown, times something. So what do? I divide both sides by that something. That something is RT plus 1. Some of you panicked right here. I sense it over the internet. But the panic is just because suddenly in your math. So what I just did is I just divided both sides by RT plus 1. RT plus 1. And we're assuming RT plus 1 is not 0. And RT plus 1 divided by RT plus 1 cancels. So that leaves me my P is equal to A divided by RT plus 1. And the only thing I did here is just I removed the parentheses. They're not needed. You can keep them there if you want. Okay. And one last thing. Applying a mathematical formula. So here we go with the mathematical formula. Whoops, don't need a terminal. We need my virtual blue board. So we're going to be using this formula. So let's read. This is a word problem. A person borrowed $5,240 for new furniture. They will pay it off in 11 months at an annual simple interest rate of 4.5%. Set up a formula that will indicate how much interest they will pay. Use the formula T given in years. So literally, we're using the formula I, which is equal to interest. P is called the principal. That's the amount you paid or put down. For those of you who buy houses or cars or borrow money. R is the interest rate. And T is time in years. So you have to know what those stand for. So we're going to set up a formula that will indicate how much interest they will pay. So my unknown is interest. That's how much I'm going to pay. So my principal, how much I paid down, or borrowed in this case, is $5,240. My interest rate is 4.5%. So 4.5% is not a number. How do we change it to a number? We write 4.5 divided by 100. Since percent means per 100, and T is the time, and the time is 11 months, but the time has to be in years. So 11 months is, how much of that is a year? Well, 1 year is 12 months, so that's 11/12. And that is my formula. So to literally solve this, I would expect you to literally grab a calculator, and if you were at home, and this is not a test, if you were in a test and you were asked to do this, I would give you numbers that would make it really, really easy to use without a calculator. And that's all you have to do. That's literally all that's asked. One last thing, which is some mathematical reasoning. And this will probably be on the exam. I'll have to talk to you all about this. I want you to understand the reasoning behind mathematics. Mathematics is far more than just solving equations. Solving equations is really important. But in grad school, I hardly ever solved equations. We used mathematical reasoning. So explain why the following statement is either true or false. Every equation can be placed into exactly one of the following categories. conditional, contradiction, or identity. So the way that you would do that, so that's one possible reasoning. So you would look at the definitions, and ask yourself, is it possible, and you can just consider linear equations, is it possible for a linear equation to be both conditional and contradictory? Well, an equation that is conditional is one where some numbers are solutions and other numbers are not. A contradictory equation is one that has no solutions. So it can't be both conditional and contradictory because conditional statements have some numbers as solutions. Contradictory equations don't. Can a conditional statement be also an identity? Remember, conditional equations, some numbers are solutions, others are not. But identities, every number is a solution. So it can't be both conditional and an identity, because conditional statements, some numbers are and some numbers are not. For an identity, all numbers are. So now the only thing they have to do to answer this question is to decide whether an equation can be both a contradiction or an identity. So I'm going to write this down here, mathematical reasoning. Questions like this will always be, well, I don't know. They will be given to you as bonuses. You will see them in some form. On your exam. The other thing I ask is, explain why the following two equations are equivalent. So two equations, how do you go about answering that? Two equations are equivalent if they have the exact same solution set. So you could find the LCD and solve for x, and then find the LCD and solve for x in number 1 and number 2. If their solution sets are identical, then they're equivalent. So that's all we have. It was a rather long first lecture. Like I said, they won't be this long all the time, but I'm anticipating a bit of anxiety, so I wanted to go slow this first one. Last thing, you don't ever have to watch any of these videos. You can always watch the Pearson video. If you're good at reading the text, you never have to watch a single video at all. But I will tell you in an announcement that you should at least look at the last, when I have a mathematical reasoning question, you should probably look at the very, very last part of the video and listen to what I say about the mathematical reasoning. I'm just learning how to use all of the features of YouTube, and I'm pretty sure I can make links to each one of these so you can go straight to them without fast forwarding. And that's it for section 1.1.